Hello people, this is Mr. Laxton coming at you with the Algebra I 6.4 Part 1 notes. So looking here at 6.4 Part 1, we are asking ourselves to solve absolute value equations. So if you remember in the beginning of the year, we talked about absolute values a decent amount. Now we're solving equations that deal with those. We're getting away for a day here or so from inequalities, so with less thans or greater than or equal tos, and we're just using equations today, so we just have equals. So we're not going to graph anything on any number lines. We're just solving these equations, all right? So remember, if you remember back to the beginning of the year, absolute values, everything that comes out of an absolute value is always positive. So the absolute value of -8 is +8. So everything that comes out of an absolute value is positive. It's the distance that we're away from 0, and distance is always positive. So the definition of an absolute value equation, it's an equation with an x inside of the absolute value symbol. So we are going to have an x. So notice in these examples down here, there's x inside those absolute values. Absolute value equations will always have two solutions. You always need to accept the positive and the negative options. And we'll talk about that in some examples here. But remember, for these, as you go through, that you should always get two answers. All right? Perfect. This first one's a really good example because notice how I just have x inside the absolute value. I don't have, like down here, this has like 2x minus 3. This one just has x. And this really kind of helps me imagine, like, hey, what numbers could I actually put in here for x that if I took the absolute value of it, that you would get 8, right? So if I ask myself here, well, I know that the absolute value of 8 is 8, right? Because it's 8 away from 0. And I also know that the absolute value of -8 is 8. So that's actually going to be our two answers, is that x could equal 8 or x could equal -8. So you always accept the positive answer and the negative answer. And again, you can always go back and plug this in and check to see that you got it right. The absolute value of -8 is 8, and the absolute value of +8 is 8. All right? So that's really what we're going to do here for these next ones, but they become a little bit trickier. Notice here for the second one, we have the absolute value of x minus 3 equals 4. So this stuff inside the absolute value, when you take an absolute value of it, it could be 4. So what that tells me is that this stuff, this x minus 3, could either equal 4, or the x minus 3 could equal -4. Right? Because when I take the absolute value of 4, I get 4. And when I take the absolute value of -4, I also get 4. Right? So really, that's going to be kind of the only goal for us today. And then now, like, we know how to solve these equations. The only difference for these absolute values is that you break them up. You set one equation equal to the positive and one equation equal to the negative. Notice that the x minus 3 stays. If I add 3 now to both sides, I get x equals 7. And if I add 3 over here, I get x equals, well, -4 plus 3 is -1. All right? Again, get two answers for these, and they're both going to make this right. Notice if we actually plug these in, if I plug in 7 minus 3, well, I know 7 minus 3 is 4, and the absolute value of 4 is 4. If I plug in -1 minus 3 is -4, and I know the absolute value of -4 is 4. So they check out. Both of them work. All right, so you can always check your answers in math. That's a nice thing. Cool, as we move on to example number 3 here. Again, I just want to create two equations. I want 2x minus 3 to equal 9. And I also want 2x minus 3 to equal -9, because I know that the absolute value of 9 and the absolute value of -9 are both 9. Perfect, so now we need to solve these. I need to get the x all by itself. Well, I need to add the 3. And the nice thing about these, you can do the same step for both of these equations because they're the same on the left here. Is equal to 12 here, and then these 3's cancel out, so I get 2x is equal to -6. And my last step, I can divide by this 2 to get rid of that 2, and I get x equals 6, and I get x equals -3. All right, so I get 2 answers there. You could work them down to separate equations, or you can kind of work them together like I did there. All right. Notice again, you could plug these in to make sure you get the right answer. When you plug in 6 for x here, it's going to be 12 minus 3, which is 9. And then when you plug in -3, it's going to be -6 minus 3, which is going to be -9, and the absolute value of that -9 is 9. All right, so absolute value equations. This one's really similar to the one that we just did, but we'll do it here for just sake of another example. We set 4x plus 2 equal to 18, and we set 4x plus 2 equal to -18. Notice again, and here's a common mistake that students make, is that I didn't change this at all. The 4x plus 2 stays the same. The only thing that I added was one's the positive 18, and the second one is the -18. All right, perfect. Now we need to solve these straight down. Well, I got to get x all by itself. I want to subtract this garter away from there. These 2's are going to cancel each other out, and I'm going to get 4x is equal to 16. These 2's are going to cancel out. I'm going to get 4x is equal to -20. And when I divide by 4 to all of these parts here, I get x is equal to 4, and I get x is equal to -5. All right. So those are my 2 answers. Again, you always get 2 answers for these. You could plug it in. If I plug in 4 for x here, 4 times 4 is 16, plus 2 is 18. This -5 in for this x would make -20 plus 2, which is -18. And the absolute value of -18 is 18. So we're good. Notice that this very last one here has a tiny difference. There is a number outside of the absolute value that is on the same side of the equal sign. So what your goal is that you want to get these absolute values all by themselves on the left or the right-hand side. So you want to get them all by itself. So what I want to do is my first step is to subtract 3. Because notice that this 3 is on the same side of the equal sign. So now I have the absolute value of 5x plus 1 is equal to 11. All right. And now, essentially, this becomes the same problem as kind of like what we had up here. I have the absolute value of something is equal to a number. So I need to split this up into 2 equations. I have 5x plus 1 has to equal 11. And I know 5x plus 1 has to equal -11. So you always accept, as we talked about up here, you accept the positive and the negative options, right? So I accept positive 11 and -11. Now we solve these straight down. I'm just going to do this one kind of the left side, and then I'll flip over to the right side. I need to subtract this 1. So now I get 5x is equal to 10. These 1's go away. If I divide by the 5, I get x equals 2. All right, so that is my first answer, and then I also need to solve the other side here to get my second answer. So I again need to subtract the 1. Again, it's kind of nice because you end up with the same steps to solve here, and then I divide by 5. So when I divide by 5, notice here that this just doesn't come out to be a nice number. 5 does not go into 12 nicely. So this is just, you can just leave it as negative 12 over 5. You could write it as 2 2/5. That's fine as well. But leaving that as an improper fraction is fine. All right. So again, you can plug those back in and check, but you got 2 answers because I accepted the positive 11 and the negative 11. All right. Again, be careful on these, like this last one. If your absolute value symbols are not all by itself, you got to get rid of that number that's outside of there first before you break it up. All right, so hope this video was helpful on solving absolute value equations. We will take a look at the worksheet when I return.